Hello everyone, hope you are doing well. This is Manish Seswal. Today we are going to solve our MCQ quiz solution. Uh, this is day one solution we are going to discuss in detail, and also I will share some tricks or tips by using which you can tackle it uh, by the technique called uh, this option rejection, or some other tips I will share with you so that you can save time. But yeah, understanding the core detail is also important. So we will understand the core concept also, and also to save time, we will share the tips, whatever you need. Okay. So on day one, we had shared these four questions. Four questions are here. So you can see our four questions. So first question is the area bounded by y equal to 2x plus 3 and x equal to 3 in the first quadrant is. And we have four options, right? So options are 9 by 4, 18, 9, 4. So to solve this question, we can simply draw the graphs, how the graph looks. So, and then also we, in our mind, it should trigger that this question is from calculus integration thing, right? Because in integration there is to become area calculation thing, right? So I have taken the first question here. So this is the first question, right? So we have two lines, y equal to y equal to uh, 2x plus 3, and next line is x equal to 3. So this is the green line. This green line is x equal to 3 9, right? This is a straight line which is parallel to the y-axis. So on this line, when you see the x point, it is always constant, that is 3, and y point varies similar to y-axis. And for this line, this is the y equal to 3x plus 2x plus 3 line. So how I have drawn this line is, when you put x equal to 0, you have y equal to 2 times 0 plus 3, that is 3. So when you put x equal to 0, y equal to 3, so it will pass through this point, right? I will write it here. So it will pass, this line will pass through 0, 3. When you put in this line, when you put y equal to 0, so it will be 0 to x plus 3. So it will give you x equal to minus 3 by 2, that is minus 1.5, right? So this line will also pass through this point, and when you draw this, right, so this will be the straight line. So how did I find that it will cut here? So it is like, this line is, green line is x equal to 3, right? So when I will put x equal to 3 in this equation, what is the y point I will get? 2 times 3 plus 3, that is 2x. We have 2x, the point is uh, 2x plus 3, right? So the point we have is 2 times 3 plus 3, that is we will get 9, right? So this point will be actually 2 3 9. Okay. So our this uh, when you substitute the value of x, that is 3, in this equation, and you see that it intersects, these both line intersects at 3 9. So this will be our point, right? So, and you see the area bounded by y equal to this and this in first quadrant. The area, total area bounded are more, like these are also the area bounded, right? These areas are also, these areas are also bounded by them. But in the first quadrant only we want. So in first quadrant, the area bounded by these two lines are this shaded region are the only area bounded by these two lines, right? So, and the limit of this is, limit we can say, see in terms of x. The boundary for this region is x equal to 0. This line is x equal to 0, right? This line is x equal to 0 line. So boundary for this x, the boundary with x is x equal to 0 to x equal to 3, and other boundary here is this y equal to 0 line, right? And next boundaries, there are four boundaries, 1 2 3 4. So one boundary is this line and one boundary is this x equal to y equal to 0 line, right? So in general, what we have, area formula, area of region formula. So area of this shaded region will be integration of y dx from x equal to 0 to 3, because we have the left limit x equal to 0 and right limit x equal to 3, and y dx, this is the formula of area, right? This is the formula to calculate area using integration. So when you substitute value of y, that is 2x plus 3, we get this 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 equation, right? This equation. Now after using the formula of integration, that is this 2 will be, this 2 is constant, right? So 2 will come out, 2 will come out, you have x. So integration of x is what? X square and by 2, that is to the here power of x is 1. So when you integrate it, x dx, so it will become x to the power 1 plus 1 by 1 plus 1, that is n plus 1 by n plus 1, right? Similarly, when we integrate a constant, that is just this thing 3, and then we have 3, this is constant, it will come out, then integration of dx, integration of dx is simply x, right? So this is what I have written here, and this value has to be evaluated on limit what? From x has bound left limit of 0 to right limit of 3. And when you substitute this, we know substitution of, right? First we substitute the upper bound, then we subtract the lower bound, subtract by putting the lower bound values in the variables, right? So we can see that these 2 and 2 get cancelled, and we have x square term plus 3x from this thing, right? So now we'll substitute the value of x. First we substitute 3 and then we'll substitute 0. So these 2 get cancelled, then we have, when you put 3 square plus 3 times 3, right? And when you put 0, this term also will be evaluated to 0, and this term will also be evaluated to 0. So we have final answer is 3 square 9 plus 3 times 3 9, so that is 18. So 18 is our right answer, right? 18 is our right answer, that is option B. So this is what I did in detail process, right? But in exam, this was asked in 2071 IOE exam. So in exam, and it was asked for 2 marks. So for 2 marks, you have less than for 2 marks you have less than 2 minutes, right? You have less than 2 minutes. So in that time, if you'll do these all, you'll have like less time for other questions. So what you do is you just draw this diagram, don't say it this much, just for information, don't do this numberings and all, just draw x-axis, y-axis, and then this, and then just note down the intersecting points, right? Then when you see that, and then play with options. So when you see there, this shaded region, that region for which we have to calculate the area, you can see that it forms a rectangle here, right? It forms a rectangle here. It forms a rectangle of 3 by 3, or you can say it's a square. So this square itself, or the rectangle itself, has the length of 3, breadth of 3. So this small portion has area of itself 9, right? 3 times 3 9. So do you think the whole area will be less than 9? No. So this option gets rejected, right? Because this has 9 and still we have to calculate this area. So this area gets rejected. This is also less than 9, because already we have 9 square units for this. So this also option gets rejected. And when you see this, you can guess na area, like for triangle, it is a triangle. So it has this base of 3 and height of 5, 6, right? Height of 6. So 6 times 3 18, 18 18 divided by 2, that is 9, right? So 9 plus 9, it's 18 area, it's coming. You can do it without also integration, you can do, that is part by part, right? one you can calculate the area of rectangle, you can calculate. But the one I was teaching was the option rejection concept. So this small portion has area itself 9, so this cannot be option, this cannot be option. Again this has also 9, so of course this can also not be the option. So in way of rejection, like rejecting option also, you can calculate it in less time. So this is what the tips was. So in exam, you don't need to show proper steps, like I wrote na area of shaded region all. You don't need to write, just do. Even if you are doing with the equation, just start with this equation, right? Just start with this equation, uh, directly put this, or you can directly substitute value of y also. You don't need to write this step also, and then write this, then integrate it, and then you don't need to write these all steps, just write this step, and in this only put value of x, and then 0 voila, you don't need to put, and then evaluate it and see the options. So if you are solving in this way whole process wise, you don't need to do the formalities as we do in the written exams. This is the MCQ. You just need to choose the best answer out of the available 4 options. And also the next one concept that is most useful for MCQ exams are rejecting the options. So that way also you can save time, and even you can solve it in like 1 minute time. So that's it. I think this is we are good with question number 1. So we will move to question number 2 now. Okay, fine. Now moving to question number 2, we have equation of circle touching x-axis and center at HK. So just look at the question very nicely. It's touching axis. What do you mean touching axis? Is touching means its boundary is touching, right? Not the center. Its boundary is touching. So its boundary is touching x-axis and center at HK. So HK is any general point. It can be in any quadrant. So HK, like H and K can value a positive, negative. So it can be any quadrant. So for general point, we take HK in first quadrant, or any quadrant you can take. When it touches x-axis, so touching x-axis means something similar, or it could have been something like this. Something like this also it could have been. Something like this also it could have been, or something like this, or something like this. So any of the four cases would have been right. And this center of any of the circle, you have like it is in terms of this variable h and k. Oh, sorry, constant h and k, but h and k value are unknown, right? So it's still a general point. So when it touches x-axis, we can see that the y coordinate we have na k value, that is equal to the radius of the circle, right? Radius of the circle. So because k is how much above this x-axis, it is the center is how much above x-axis, that is k, that y coordinate of the center. So we have radius equal to k. I think, I guess, I hope you understood, right? So uh, we have a circle with center HK that is given, and now we have also the radius, right? So we have one standard formula, equation of a circle with center at HK and radius r is given by x minus h whole square plus y minus k whole square equal to r square, right? So now when we substitute the value of r here, that is k, we get x minus h equal x square plus y minus k whole square equal to k square. So this is our answer. It is found in our this option C. So this is the way of writing, doing it in proper long form. But when you are doing in exam, you can just plug these points, this center points. Sorry, when you are doing an exam, you can see that uh, when you have HK as center, so you have HK as center. So if you put the value of x and y as HK, it should not be satisfying. It should not be satisfying because uh, for a like circle, when it has a radius more than 0, the center will not lie on its boundary, right? This center will not lie on its boundary. So if center will not lie on its boundary, it should not satisfy the point. That point should not satisfy, na? But here you can see when you put hk here, h square plus k square, it will be giving this. So this is satisfying. You can reject this, right? So that way you can reject also, but like simple, it is in a standard form. So you can just do it x minus h square plus y minus k square equal to r square, that is k square. So that is also simple. It's not long term. Other way you can think of. So now solving this, we have option this C as correct answer. Now let's move to question number 3 for this quiz 1. So I hope this question is clear to you. It's visible properly. So the 4th term, 7th term and 10th term of a GP are Q, P, Q and R respectively. Then what is the relation between P, Q, R? We have to find. So let me recall what GP here. GP here is geometric progression. So what we have in geometric progression, we have common ratio, right? Common ratio, and also in geometric progression we have mean, and that is geometric mean. So property of geometric progression is that we have common ratio between consecutive terms of the sequence. For example, if we have sequence 3, 9, 27, 81 and so on. So first term is our T1, that is 3. Second term is 9, that is T2. Third term is 27, that is T3, and fourth term is 81, that is T4, and so on, and we have up to Tn terms, right? That is nth term. So also note that the first term in our geometric progression, we call it A, right? We denote it by A, also with T1. So when we calculate common ratio between consecutive terms, we see that common ratio R is equal to T2 by T1, T3 by T2, T4 by T3, and so on. This common ratio will be equal for all consecutive terms, right? Now when you see from this we can see, and this we can bring this relation, right? T2 will be T1 times we transpose T1 to this side. So T2 will be T1 times R, right? So T1 is also written in form of what? A. So it will be like A times R. T2 will be A times R, right? So now from this one, when you transpose T2 to towards this R one side, so you get this, right? You get this. So T3 equal to T2 times R, and we have already calculated the value of T2 here, so we'll substitute it here. So T2 value is A times R, that is A times R. Then we have A to the power A times 2 R square. Now again from this term we have T4 equal to T3 times R, because we are transposing this T3 to towards the side of the R. So T4 equal to T3 times R, that is A R square, and we are substituting here the value of T3. So A R square times R equal to ARQ, and so on. So when we have Tn, we can see that for each of the terms we have A and R to the power that term minus 1, right? So we have Tn equal to A to the power A times R to the power n minus 1. So this I just wanted to recall the property of geometric progression. Now we are given that our term for 4th term is P, 7th term is Q, and 10th term is R. So from this Tn formula, we have T4 equal to A to the power. Since R is already used here in the questions, so if we are denoting the common ratio with again the small r, that is lowercase r, we can get conflict, right? So for the sake of the resolving this conflict, I am just using capital R for common ratio. Capital R here is capital R. Here is our common ratio. Capital R, common ratio. Common ratio. So T4 equal to A to the power R minus 1 from this formula, that is, and P4, P, that is P, right? So we have A R Q equal to P, and similarly for T7 and T10. T7 equal to Q, it is given, right? Now T7 value when we calculate, A R to the power 7 minus 1 equal to Q, that is A R6 R to the power 6 equal to Q. Now T10 we see R is equal to T10 we are given that it's R. So we use this formula and calculate AR 10 minus 1 equal to R. Now we can see that AR to the power 9 equal to R. So when we observe when we observe this, or simply try with option now. Try with option. When you try with option, you see that first try with the simple options, right? Simple options like without this plus thing, multiplication wala. So you see that Q square times Q square equal to PR. So Q square means Q square. When you do Q square, that is A square and R to the power 12, right? Don't do 36. It's 2 times 6. And when you do this thing, sorry, when you multiply both of these P and R, what you will get? A R Q times A R 9, R to the power 9. So you will get A square R 12. So when you play with option, you can get this B option. Again, that you can reject other options by checking it, and by satisfying these options, we can get B. Other technique is that we can observe that this T4, T7 and T10, when you calculate common ratio between them, you see that the common ratio is R3. So these three are itself in again what? These three are itself again in GP. These three are in GP, right? Are in GP. So in GP, we have three terms, right? So the middle term is what? Geometric mean. Geometric mean. So what's the formula of geometric mean? Geometric mean, if you calculate, what you will do? You do the left side also, or the root of the left and right, right? So left is this one P and the right is Q. So you have Q equal to PR. So by using the concept of geometric mean, you can do. Or the common ratio, when you substitute the value P Q by this, because T4 T7 by T4, right? T10 by T7. So that also when you substitute Q by P, R by N, this when you just transpose this Q to this side, PR Q square equal to PR. So option B will be our right answer. Got it? So simply you have to use the geometric progression concept, the concept of geometric mean, and even you can play with options, or like you can do it, right? So we are done with question number 3 also. Now let's move to question number 4. So our question number 4 is a limit question, right? So this is limit question and we have 4 options. So for this, when we substitute the value of the limit of this x, so x tends to infinity. So when you substitute this and check it, so when you substitute this here, you see that it will form what? Infinity by infinity. So infinity by infinity is what? Indeterminate form. So for this case, we have studied in our mathematics that we can use L'Hospital rule. L'Hospital rule when it is in the form infinity by infinity or 0 by 0. So what does L'Hospital rule says? To differentiate both numerator and denominator with that variable in which the limit is, right? So here x is the limit variable. So we differentiate both numerator and denominator with respect to x. When you differentiate this whole uh, polynomial, that is equation, so we get what we get is 7 is constant, right? So 7, say it will be 7 itself. And when you differentiate x cube, what you will get? When you differentiate x cube with respect to x, what will you get? 3x, right? 3x square. When you differentiate x square with respect to x, what will you get? You get 2x, because what is the derivative formula we are using here? Dx to the power n is equal to n times x to the power n minus 1, right? So this is the derivative formula we are using, and derivative of constant is 0. Derivative of any constant, numerical constant, is 0. So note it down, just recall, for your recall I am just saying. So when you differentiate this, you get 7 times 3x square plus 3 times 2. This power n, power is here, value of n is 2. So 2 times x to the power n minus 1, that is 2 minus 1 1, and this is constant. The derivative of constant is 0. Similarly, we'll do the derivative of this, that is 2 times 3 this thing, and then when you do this mathematical calculation, we have 21x square plus 6x 6x square plus 14x, this one. So again, when you try to substitute the value of x to limit this limit value over infinity, it is again the forming infinity by infinity form. So if it is in the form of infinity by infinity, it is very good for us that we can use L'Hospital rule again, right? So use L'Hospital rule again. So we'll have this equation when you use L'Hospital, that differentiate both numerator and denominator with respect to x. Again, when you check, it is again forming infinity by infinity. So again use L'Hospital rule. So when you use L'Hospital rule again, then it will form this 42 by 12, and when you divide both numerator and denominator by 6, you get 7 by cancel 6, like both are divisible by 6, right? So 6 7 are 42, 7s are 42, and 6 2s are 12. So 7 by 2 is our right answer. So this was using L'Hospital rule. But for exam, what you can do is, you can just see if it is in form of infinity by infinity and higher derivative term, higher power in terms of x, if you see in both of the numerator and denominator higher power terms of x, if they have the same higher power, you can simply do is, you can write the coefficient of both, and that will be your answer. So for example, in this case, you can see the coefficient of xq in the numerator is 7, and the coefficient of xq in this denominator is 2. So our final answer will be 7 by 2. This is what we got after this all calculation. So for in exam, if you want to save time, and just check whether the higher power term in numerator and denominator are same, that is xq here. So our answer will be the this ratio of the coefficient of the higher power terms in the numerator by the higher power terms, coefficient of the higher power terms in the denominator. So 7 by 2 is the right answer here. So we are done with our 4 questions of day 1 quiz. So thank you everyone for this watching this video solution. We'll come again with more video solutions for other further this consecutive day quiz. If you have any doubt, you can ask us in comment section or reach out us on our Facebook page so that we can solve your doubt. And also we'll be bringing more and more qualitative video that is more probably to come in IUA entrance exam or JEE exam, in exam for your BE entrance or BTech entrance exam. So thank you for watching this video. Okay, bye.